Hello everyone. Once again, welcome to PM Networking. Guys, today in this video, we are going to configure the whole network. As you can see, this is my topology in front of you. In this topology, we are going to configure multiple protocols like DTP, VTP for VLAN, DTP for trunking, EtherChannel between switches. We are going to configure port security, OSPF, NAT, or you can say PAT. We are going to configure VPN. We are going to configure RSTP, like STP type, and these protocols, HSRP. See, first of all, let me make you familiar with this topology, guys. See, we have two sides. Let's say this is side A1 and this is side 2. Both sides are connected with each other through internet. So these users should be able to communicate with internet as well, and these users should be able to access the resources which is available on remote site as well. So for the internet connectivity, we will configure PAT on this router, or we can configure dynamic NAT. So I will configure PAT on this router and on this router. For the communication between these two sides, we will create one tunnel between router 1 and router number 2. I will configure point-to-point VPN over here. You can see this is the IP address of VPN. Okay, this will be the edge technology, edge configuration. After that, inside the network, here you can see link between switches must be configured as trunk. So we will use protocol DTP protocol for the trunking. After that, first of all, I will start configuration from the scratch. First, I will define IP address to the host, to the client machine, and as you can see, these two machine belongs to VLAN 10, these two machine belongs to VLAN 20, these two machine belongs to VLAN 30, and these two machine belongs to VLAN 40. So I will create SVI on distribution layer switch over here. On both switch we will create SVI. Let's say here I will create SVI for VLAN 10, for VLAN 10, and IP address for VLAN 10 is 10.1.1.254. As you can see, I am using IP in VLAN 10 from 10 subnet. 10.1.1.0 is the subnet for VLAN 10/24. In the same way, for VLAN 20, I will configure 20.1.1.254 SVI. For VLAN 30, I will create 30.1.1.254. For VLAN 50, for VLAN 40, I will configure 40.1.1.254. On switch number 2, I will configure, let's say, for VLAN 10, 10.1.1.253. Or on switch number 1, we can configure 10.1.1.253, and on switch number 2, 10.1.1.254, anything. After that, as you can, between switch 1 and switch 2, distribution layer switch, I am using multiple link. So I will configure here EtherChannel. Through EtherChannel, we will bundle these link, and I will configure layer 3 EtherChannel. So on layer 3 EtherChannel, as you know, we can configure IP address. So I will configure IP from this subnet. Okay. After that, by default in the routing table of switch 1, there will be this network, 11 network, 12 network, and all VLAN network 10, 30, 10, 20, 30, 40. Right. For the reachability here, right? So actually we need to see here all LAN network to router number 1, and here we will configure what OSPF. Let's say on router number 1 we will configure one default route towards ISP. So that default route should be available in the routing table of switches as well. So we will redistribute default route in OSPF. So as you know, we are using OSPF nowadays, so that's why here I will use OSPF routing protocol. Okay, so we are going to configure multiple protocols here, like these access points should be configured as a port fast should be configured on access port, but I will enable RSTP, so we don't need to enable port fast here. Okay, or we can configure enable port fast as well. Okay guys, so without wasting our time, let's begin the configuration. First of all, I am going to start configuration from the scratch. So let's assign IP address to the VPC, to the client machine. First of all, let me configure IP address to VPC1. Here IP address is 10.1.1.1, let's say 192.168.1.1.2/255, and here default gateway will be the virtual. So I am going to define the virtual gateway, right, that I will create through HSRP or by using HSRP, VRRP and GLBP. Any protocols we can use for the default gateway redundancy, right? So my virtual gateway IP address will be 10.1.1.100. So I am directly providing that default gateway IP address to the client. So let me configure VPC2 as well. VPC2, here IP address will be 10.1.1.2/24 and gateway is 10.1.1.100. I am defining the same default gateway IP address, and this is not the physical gateway IP address. Okay, I will show you this later. Here I am going to define IP address. So VLAN 20 user are using IP address from 20 network. So let's say configure IP from 20.1.1.0. So 20.1.1.1/24 and gateway is again 20.1.1.100. Done. Then let me configure VPC4, one IP address to VPC4. VPC4 IP address is 20.1.1.2/24 and gateway is 20.1.1.100. Done. Let me assign IP address to VPC5 as well. 678. IP VPC5 is 30.1.1. Sorry. IP 30.1.1.1/24 and 30.1.1.100 will be the default gateway. Let me assign IP to VPC6. Here let's say IP address is 30.1.1.2/24 and gateway will be 30.1.1.100. Done. Now I am going to configure IP on VPC7. Let me assign one IP over here. IP 40.1.1.1/24 and 40.1.1.100. Now last VPC is VPC8. Here let me configure the IP. IP 40.1.1.2/24 and 40.1.1.100. That's it. So till now I have configured only IP address on VPC. Right now my second step will be I am going to use DTP protocol to configure trunking between switches. Okay, I will use the encapsulation protocol .1q for the trunking. This is the second configuration. After configuring IP address on VPC, I am going to configure link between switches as trunk so that VTP will work. So let me take you to access layer switch 1, and here I am going to configure two things. As you know, VLAN and link between switches is trunk. So these two interface on switch number 1 is in VLAN 10. E0/2 and 0/3 are in VLAN 10. So I will configure these two port in VLAN 10. Enable. As you know, to assign a port in a particular VLAN, command is interface range E0/2 to 3. 2 to 3 and switch port access VLAN 10. In the same way, to access layer switch 2, let me configure the VLAN first. Here I am going to say, or directly I can copy the command from switch number 1, but that will be in different VLAN. That is in different VLAN. So leave. Those ports are in VLAN 10 and these two ports are in VLAN 20. So interface range E0/2 to 3 and say switch port access VLAN 20. Done. Now access layer switch 3. Here I am going to say config T and interface range E0/2 to 3 and switch port access VLAN 30. Done. Let me take you to access layer switch 4. Here I am going to use enable config T. After that, interface range E0/223 and switch port access VLAN 40. Done. VLAN configuration is done, guys. Now I am going to configure link between switches as trunk and VTP both at the same time. So do so VTP status. By default, VTP domain name is null, and as you know, there are some requirement of VTP. First requirement is link between switches must be configured as trunk. So first I am going to configure link between switches as trunk. So let me take you in global config mode. I will say interface range E0/021. These two interfaces are connected with switch 1. So let me say switch port trunk encapsulation.1q and switch port mode trunk. Done. Do so history. I'm going to copy these two commands from here and I will paste these two commands on all access layer switch. To switch 2, let me paste the command. Done, guys. After that, on access layer switch 3, here also let me paste the command. Done. And if you want to verify, you can run command show interface trunk, and now you can see 0/0 and 0/1 is your trunk link. I'm using same link on all switches, that's why I'm pasting the command directly. Done. Now I need to take you on access layer switch 4, and here I am going to paste the command. Okay, interface range E0/021 and say switch port mode switch port trunk encapsulation.1q and switch port mode trunk. Done. I have configured the switches link between switches at trunk. Now I am going to change the VTP domain name. So let's say VTP domain name is CCNP, let's say. Done. And on any switches you can verify VTP domain name. Let's say I am verifying on access layer switch 4. So VTP status. You can see the domain name is, let me maximize it. VTP domain name is Cisco 123. VTP domain name is already configured over here. So let me check again. I think VTP domain name is already configured. I have already configured VTP domain name. So let me verify it. VTP domain name is CCNP. VTP domain name already set up to CCNP. So it is not propagating. Let me check on the switch number 2, let's say. Here I am getting one message as well. So VTP status. VTP domain name is Cisco 123. So here also on this switch also I am going to say no VTP domain name CCNP, or we can say VTP domain name Cisco 123. Let me verify the domain name on distribution layer switch. I think I have already configured the VTP in previous scenario, so that's why it's showing so VTP status. Here also VTP domain name is Cisco 123. Done. On access layer switch 1, so VTP status. Domain name is Cisco 123 and here also it is Cisco 123. And let me verify one more thing, that VLAN is propagating or not. Directly I am going to verify the VLAN on distribution layer switch. Let me run one command over here, that is so VLAN brief, let's say. So you can see VLAN 10, VLAN 20, VLAN 30 and VLAN 40. All VLAN is automatically created on this switch, on distribution layer switch. So okay, VTP is working fine. So till now what we did, we configure multiple things like here we have configured the IP address, we have configured the VTP, we have configured the link between switches as trunk. Now what I am going to do, next step is I am going to configure the ether channel, right? I am going to bundle these link between switches. Or directly what I can do, I can create the SVI over here. So before creating the SVI, let me bundle the link first. So on distribution layer switch, what command I need to run? Interface range E 1/123 and E 2/0. So these four links are there between switch 1 and switch 2. So I'm going to say shutdown first here. I'm going to say no switch port because I am going to create layer 3 ether channel, and after that channel group, then group number, and after that mode. Let's say, let me use the mode on mode, static mode. Done. Now I am going to say no shut over here. No shut. Right. Now let me take you to switch number 2. On switch number 2 also let me do same thing. Config T, interface range E 1/123 and E 2/0. After that, first of all shutdown, say no switch port. After that channel group number is, let's say 10, and mode is on. I'm going to say no shut again, right? If you want to verify, you can verify. So ether channel summary. So you can see these ports are member of this port channel, and you can run one more command. So ether channel, now here you can see group state is layer 3. So this is layer 3 ether channel. Now we can configure IP address over here, and so IP interface brief. You can see the port channel status is up and line protocol is up, and you can run so interface p10 command as well. So interface port channel 10. Also you can see here port channel is up, line protocol of this channel is up. Now I am going to configure the IP address on port channel. So let's start IP configuration from distribution layer switch 1. First of all on this switch also I will verify that my port channel is up or not. So do so IP interface brief. You can see port channel 10 is up, line protocol is up. Let me configure one IP address over here. Interface P10 IP address 11.1.1.1 255.255.255.0. Let me configure IP on switch 2 also. So interface P10 and IP address is 11.1.1.11.1.1.2 255.255.255.0. I've configured the IP address. Now if you want to check the reachability between switch 1 and switch 2, you can ping the IP address of switch 1 11.1.1.1. You can see there is reachability success rate is 80%. Now it is 100%. So there is reachability between switch 1 and switch 2. Ether channel is working fine. So VLAN brief on both switches, VLAN 10, 20, 30, 40 is available. Now I am going to create the SVI. Till now, see what we did. We configure the IP address on the VPC. After that we configure the VTP, we configure the link between switches as trunk, then we configure the ether channel. Now I am going to configure the SVI. I am going to create SVI on switch 1 and switch 2. So let me take you to switch number 1 first. First of all I am going to configure SVI on switch number 1. Done. Interface VLAN 10, or I can write down the command in notepad and directly I can paste it. So let me write down the command in notepad. Here interface VLAN 10, after that no shutdown, and then IP address will be 10.1.1.254. Subnet mask 255.255.255.0. Done. Let me copy this one, and after that we need to say exit. Then let me paste one more time over here. VLAN interface VLAN 20, here IP address will be 20. Exit, and let me paste the command one more time for VLAN 30. Here IP address will become 30. Then again exit. Then let me paste one more time for VLAN 40. 40 IP address will become 40.1.1.1. Done. Exit. Let me copy this and let me paste it in global config mode of switch 1. Okay, hope guys you guys are getting me what I am doing here. Okay, see, I've created the SPI for VLAN 10, 20, 30 and 40. On all SVI interface I have assigned the IP address. If you want to verify that your SVI is up or down, so IP interface brief, you can see so IP interface brief, you can see your SVI's interface are up. Done. Now I am going to create SVI on switch number 2. So let me modify over here. On SVI on switch number 2, let's say my IP address is 253. For VLAN 10 also, for VLAN 20, 30, 40. Rest configuration is same. You can see. Let me copy this and let me paste this command on which switch guys? Switch number 2. So let me take access of distribution layer switch tool, go to global config mode, and here I am going to paste it. Done. If you want to verify, so IP interface brief, now you can see your SVI's interface are up. Now till now we had configured the SVI, EtherChannel, VTP, trunking and IP address to VPC. Now my VPC should be able to ping the SVI interface. So let me verify that VPCs are able to ping the SVI interface or not. Here from VPC 1 I am going to ping 10.1.1.254. Let me check that this PC is able to ping or not. So you can see VPC 1 is able to ping the SVI interface of VLAN 10. In the same way VPC 2 should be also able to ping. So from VPC 2 also you can verify ping 10.1.1.254. Done. It is able to ping, and it should be able to ping the other SVI interface also, because one SVI interface is running on switch number 2, that is 253. So it should be able to ping this IP address also. You can see both SVI is reachable from the LAN user, and VLAN 10 user can ping to VLAN 20 user as well. First of all, from VPC 3 I am going to check that VPC 3 is able to ping. VPC 3 is member of VLAN 20, so I am going to ping the SVI of VLAN 20 254. See, and 243. 253, sorry, not 43, 53. See, both SVR are reachable from here. Now if VLAN 10 user want to ping VLAN 20 user, let me verify that this VLAN 10 user are able to ping VLAN 20 user and 3040 or not. So ping, I'm going to ping VLAN 20 means which VPC? VPC 3 from VPC 1. So ping 20.1.1.1. This is the IP address of VPC 3. Let me hit enter. This one is not able to ping. Inter-VLAN communication. Okay, but it should ping because we have SVI, both machine, both VLANs are able to ping their SVI interface. So it should be able to ping. But why it is not able to ping, guys? The reason is so the default gateway. Whenever you will ping to the user who belongs to different subnet, it will forward traffic to their default gateway, and now this default gateway is not reachable because this is the virtual gateway. So what I am going to do now, I am going to configure HSRP protocol so that this default gateway should be reachable from the VPC. For now, if you will ping 10.1.1.100, it will not work. as you know, because this is not exist, this IP address still now not exist. So what I am going to do, I am going to configure HSRP protocol on switch 1 and switch 2, distribution layer switch 1 and switch 2. So here what I am going to do, say interface, wait guys, here I am going to say standby, after that group number. So here we cannot run this command, we will run this command on the interface. So let me take you to interface VLAN 10, and here I am going to say standby, after that group number is, let's say, 10, and then IP, after that the virtual IP address, that is 10.1.1.100. done. This is the virtual IP address for VLAN 10. Okay, hit enter. After that exit interface VLAN 20, and now if, let me check that now VLAN 10 user are able to ping this gateway or not, because this gateway should be reachable now. Okay, it will take some time. After some time you can see here, so standby. Now this router is not active, this router is standby. After some time this router will become active. Now you can see this router is active, and now if you will ping from VPC1 to this IP address, you can see this is, it is getting reply, right? So now this IP address is reachable. For VLAN 10 I have done the configuration. Let me do same thing for VLAN 20 and 30, 40. So interface VLAN 20 standby, after that group number 10, and then IP address 20.1.1.100. done. Exit interface VLAN 30, after that standby group number 10, and IP is, let's say, 30.1.1.100. this is the IP address. Then interface VLAN 40 and IP address 40.1.1.100. done. Sorry, standby group number 10, IP 10.1.1. sorry, 40.1.1.100. done guys. I've created I have configured the HSRP on switch number 1. Now let me configure HSRP on switch number 2. So directly what I can do, I can copy the command from switch 1, do show history. Let me copy all command from here. Interface VLAN 10 standby, not from here. Interface VLAN 10. Okay, this is the virtual IP address for VLAN 20, 30, 40. So till here I am going to copy the command, and let me paste this command on switch number 2. Paste it. Done. And so standby. So you can see when I am running so standby command for VLAN 10, group number 10, state is listening. It will take some time. After some time this switch will become what? Standby. As you know, see, standby for our VLAN, because switch 1 have the higher IP address. Let's say switch 2 is my primary switch. I want that all traffic should be forwarded to the internet from the LAN user via switch number 2. So what I can do, I can increase the priority over here. But for now switch 1 is active, so until and unless switch 1 will not goes down, switch 2 will be in standby. So we have redundancy, don't worry. Okay, for VLAN 10. Okay, now I am going to run again this command, so standby. So you can see this one, this switch is standby, and active is a virtual IP address is this one, and active router is 10.1.1.254, means switch number 1. By default priority is 100. Okay, so everything is working fine till now, and now different VLAN users should be able to ping each other. Like VLAN 10 can ping VLAN 20 user. Now let me check first of all this IP address, so you can see VPC1 is able to ping their virtual gateway IP address. In the same way, VPC3, which belongs to VLAN 20, should be able to ping their virtual IP address, that is 20.1.1.100, and you can see it is reachable. In the same way, switch number means VPC number 5 belongs to VLAN 30. So let me ping 30.1.1.100 from here. You can see this is also reachable, and from VPC 7, which belongs to VLAN 40. So let me ping 40.1.1.100. Done. So this one is also able to ping. Now I am going to check the inter VLAN communication. So from VPC1, which is member of VLAN 10, I am going to ping VPC3, which is member of VLAN 20, and IP address of VPC3 is 20.1.1.1. Now you can see I am getting reply and there is connectivity. In the same way, let me ping the 30 user, 30.1.1.1. Yes, reachability is there. Let me ping the 40 user, VLAN 40 user, ping 40.1.1.1. Done. Okay. So till now my LAN users are able to communicate with each other. There is inter-VLAN communication. We have configured EtherChannel, we have configured HSRP, we have configured the DTP, VTP, and the IP address on VPC. Now I am going to configure what? See here. First of all, I'm going to configure one IP address over here. Means I'm going to make this interface as layer 3 interface, this interface as layer 3 interface, and then I will configure the IP address so that there should be reachability between router 1 and switches. Okay, so by default these two interfaces are switch port, means layer 2 ports. I am going to make these ports, these two ports are as layer 3 port. So let me take you to switch number 1, distribution layer switch 1. Here interface E0/0, no switch port, and now you can configure IP address over here. IP address 12.1.1.1.1, let's say 255.255.255.0. Done. I've configured the IP address over here. Now let me take you to switch number 2. On switch number 2, config T, interface E0/0, no switch port, and IP address 13.1.1.1, 255.255.255.0. Done, guys. I have configured the IP address over here. You can verify. So IP interface brief. This is completely real-time scenario. Okay, in real time you need to configure sometime this type of scenario. So here you can see I have configured this IP address. Okay, now what I am going to do, I am going to take you to router number 1. On router number 1 also I am going to configure the IP address. On router, say no, enable config T, and interface F0/0. This interface is connected with switch 1. So here I am going to configure IP 12.1.1.2 to 255.255.255.0, no set. Exit interface F1/0. This is connected with switch number 2. So here I am going to configure IP from 30 network. IP address 30.1.1.2, 255.255.255.0, no set. Done. Exit. Now I am going to configure IP address on WAN interface, that is F2/0. Say no set, no set, and IP address. Here I am going to configure IP 1.1.1, 255.255.255.250, 2. Done, guys. I have configured IP address on router number 1. Let me check the connectivity with switch. Ping 12.1.1.1. Done. Ping 13.1.1.1. I'm able to ping both switch 1 and switch 3. But so IP route. This router does not have the SVI network, right? So I'm going to configure routing over here, or you need to exchange your, more routes over here in your enterprises network, in your inside network. So you can use any routing protocol. We can use ESRP, we can use OSPF, we can use REAP, we can use BGP as well. Okay, I am going to use OSPF, but I will not advertise WAN interface in OSPF. Okay, router OSPF, after that process ID 1, network 12.1.1.1.0, wildcard mask 0.0.0.255, and let's say area is 0. Let me advertise one more network, that is 13.1.1.0. Done, guys. Now let me configure OSPF on multi-layer switch. So let me take you on switch number 1 here, and a router OSPF 1, network 12.1.1.0, 0.0.255, and area 0. Right now OSPF neighborship will come up between switch and router. Soon it is going to come up. Wait. So IP OSPF neighbor, it is in two-way state. It will take some time. Switches is going to take some time. After some time you will see neighborship will come up. Router OSPF 1. Now I am going to advertise my SVI networks in OSPF. So network 10.1.1.0, 0.0.255, area 0. Now you can see neighborship is up, right? In the same way, 20 network also I am going to advertise it in OSPF, and 30 network also I am going to advertise it in OSPF. Why I am advertising these networks? So that R1 should receive this network, because my LAN user is going to access internet. Okay, so I have advertised all network in OSPF on switch. Let me do same thing on switch number 2 also. On switch number 2, config T, router OSPF, process ID 1. First of all, network 13.1.1.0, 0.0.255, area 0. Then network 10.1.1.0, 0.0.255. See, both switches advertising same network, area 0. After that 20, then 30, and then 40. So we have configured routing as well, right? So IP OSPF neighbor, done. So there is OSPF neighborship between switch 1 and switch 2 as well. Switch 1 and switch 2. So IP OSPF neighbor, you can see how many neighbor are there. This is between switches 4 VLAN, 10, 20, 30, 40, and this is the OSPF. Now if you don't want to form OSPF neighborship between switches, what you can do? This is question, guys. You can configure this interface as SVI interface. SVI, sorry, I am saying SVI, passive interface. Right? From the passive interface, router does not send the OSPF message. So let me do that. Router OSPF 1, and say passive interface VLAN 10, VLAN 20, VLAN 30, VLAN 40. So IP OSPF neighbor. If you don't want to form neighborship between switches, right? Like this, you can configure passive interface on switch as well, on switch 1 as well. Passive interface VLAN 10, VLAN 20, VLAN 30, VLAN 40. Done. And here also now you can see so IP OSPF neighbor. Done, guys. Now router 1 will have all these prefixes in their routing table through OSPF. So IP route OSPF. You can see this router have 10, 20, 30 and 40. Done. Now till now we have configured the routing. Now I am going to configure PAT over here. PAT on router number 1 so that my LAN user can access internet, because till now LAN user cannot ping 8.8.8.8, right? Ping 8.8.8.8. It will not ping, right? And I have not configured, I think, internet router. So let me configure internet router as well. Say no. Enable config t host name internet and interface loopback 1 and IP address is 8.8.8.8 255.255.255.0, let's say. After that interface F0/0 no shut and IP address. IP address over here is 1.1.1.2 255.255.255.252. Sorry. Done. Now let me check the connectivity between this router and my edge router. Ping 1.1.1.1. It should be able to ping. Yes, it is able to ping. Now I am going to close this, and from router number 1 you can see I can ping 8.8.8 or not. Till now I cannot ping 8.8.8 because here I am going to configure one default route towards the ISP. After configuring the default route towards ISP, router 1 can ping 8.8.8 from the WAN interface only, not from the LAN interface. So config t IP route 0.0.0.0.0.0.0.0 and next hop IP address is 1.2 and exit interface is F2/0. Done. Sorry, what happened? First we need to define the exit interface F2/0 and 1.1.2. This is how we configure default route on edge router, right? Now ping 8.8.8.8. Yes, I can ping 8.8.8, but I cannot ping 8.8.8 from the LAN interface source. Let's say fast Ethernet 0/0. From this interface, it will not work. So we need to configure what? PAT over here. We need to configure NATing. Network address translation is required. So to configure NAT, first of all, we need to configure access control list. So let me configure one access control list. Access list, let's say 10 permit NA. Done. After that IP NAT inside source, match source from list number 10 and interface F2/0 overload. This is the PAT configuration. Now let me verify that I am able to ping 8.8.8 from my LAN interface or not. Still I am not able to ping 8.8.8 from my LAN interface. Let me verify why. So access list, there is no any match. No access list 10. After that access list 10 permit IP NA. Sorry, it will take now few seconds. Let me configure access list by using access list, IP access list, standard 10 permit, IP permit, and host is any. So if I am pinging 8.8.8, ping 8.8.8.8, and source is fast ethernet 0/0. Okay, we need to configure now inside and outside. Sorry, that's why it's not working. Otherwise access list is working fine. I forget to configure inside and outside. Interface F0/0, IPNet inside, exit. Interface F1/0, IPNet outside. Sorry, this one is not outside, this one is also inside. No, and IPNet inside. And interface F2/0, this one is outside. IPNet outside. Done. Now ping 8.8.8.8 and source is fast ethernet 0/0. Now you can see my LAN interface. I am able to ping from source fast ethernet 0/0 to 8.8.8. But can my LAN user ping 8.8.8, guys? Now see, ping 8.8.8. No, because switch does not have the default route now, because from here, from VPC, if you are pinging 8.8.8, so source will be 10.1.1.1, destination will be 8.8.8.8. This PC will forward traffic to their default gateway, and their default gateway does not have any route for 8.8.8.8. so IP route. In the routing table of this PC, you can see there is no default route available, right? So what I am going to do on edge router, I am going to tell to OSPF that please generate one default route. Router OSPF 1 and default information originate. Sorry, default information, or we can directly say what redistribute. We can say default information originate, or you can redistribute connected. You can run any command. Okay, default information originate. Now this router will start originating one default route in OSPF, and switches will get the default route. Now let me verify on switch number 1 that switch have received default route or not. So IP route. Now you can see default route is available over here. Now my LAN user can ping 8.8.8 or not. Ping 8.8.8. Now you can see my LAN users are able to access internet. So till now my LAN users are able to communicate with each other. There are inter-VLAN communication as well, and LAN users are able to access internet as well. Now I am going to configure the remote side, this side, guys. Okay, so let's begin the configuration of this side as well. This side also you can configure in same way like in LAN. You know, here you already know how to configure the VLAN, right? How to configure the link between switches as trunk. After that you will create the SVI over here, right? After that you will configure routing over here in this domain, and then you will configure NAT on router number 2. So let me do one thing. Directly I am going to configure router number 2 in remote side. I'm not going to configure the VLAN again. Okay, so let me configure the router 2 directly. Between router 2, edge router and ISP, this time this side I am using 2.2.2.0 network. This is not /24, or you can use /24 also. Let's say it is 30. Let me configure the WAN interface first. Interface F4/0, no set, IP address 2.2.2.1, 255.255.255.252. Done. Let me configure one IP address on ISP router. Config T interface f1/0 IP address will be 2.2.2.2 and say no shutdown. Done. Let me write the configuration and let me close the console. Here we don't need console. Okay, now I am going to take you to router number 2. So let me take you to router number 2, and on router number 2, let's say on my f0/0, let me configure one IP address. Interface f0/0, say no shut, and IP address is, let's say, anything. We can configure 50.1.1.1 255.255.255.0. Let's say here I am using 50.2. Done. And on switch number 1, here let's say I am using 50.1. Configuration will be same in this side also. Config interface f, not f, e0/0, no switch port, no shutdown, and IP address 50.1.1.1 255.255.255.0. I'm going to configure one routing protocol, let's say OSPF, router OSPF 1, and network 50.1.1.0 0.0.255 and area 0. I can configure same on router number 2 also. Here what I am going to do, router OSPF 1 network 50.1.1.0 0.0.255 and area is nothing but the 0. Right, done. OSPF neighborship will come up. So IP OSPF neighbor ping 50.1.1.1. So I am able to ping 50.1.1.1. So IP protocol, what protocol I am running, OSPF is working fine. I have performed the routing for this network. So IP OSPF neighbor. So now neighbor is in 2 ways. Soon it is going to come in full state. Okay. After that, you can see now OSPF neighborship is full. Here on edge router, you will configure NAT. So let me configure one access control list over here. Access list 10 permit any. So I have configured access control list IP NAT inside source. After that, list 10 and interface f4/0 overload. Done, guys. After that, inside and outside, so interface f4/0 IP NAT outside. Exit interface f0/0 IP NAT inside. Like this, you can configure everything, as you already know how to configure this thing. Okay, IP NAT inside f1/0 will be also inside, 2/0 will be also inside, 3/0 will be also inside. Right now I need to define one default route. So IP route 0.0.0 0.0.0 and f4/0 and next hop IP address is 2.2.2.2. Now let me check the connectivity. Ping 8.8.8.8. I'm able to ping 8.8.8 from source fast Ethernet 0/0. From my LAN interface also I am able to ping the internet. Okay, means suppose my LAN user or LAN users are able to ping internet like this. Like these users are able to access internet. Suppose these users are also able to access internet. Right, here we have one user and this user are able to access internet. Now my concern is, here is one server and these user want to access this server. Okay, so what we need to do here, we need to configure VPN. Okay guys, definitely if you want to learn everything, so you have to enroll in live training, because it is not possible to configure everything or to make long video for YouTube. Okay, so make sure, if you are a network engineer and you are thinking that your knowledge is stopping you to move further, please enroll yourself for live training once. That will be great for you. Okay, after attending the live training, you can configure these type of scenario or any scenario, right, of routing and switching. And to understand or to learn any other technology, routing and switching is compulsory. First of all, we need to understand routing switching. Okay, so in this video I am going to make you understand now VPN configuration directly between router 1 and router 2. So see, to configure VPN between router 1 and router 2, what I am going to do, I'm going to create one tunnel on this router interface, tunnel, let's say 1. After that, tunnel IP address is 192.168.10.1. Subnet mask 255.255.255.0. Done. I've created one tunnel. On the tunnel I have assigned the IP address. Now let's say tunnel source. Tunnel source is 1.1.1.1. You know this, or maybe I don't know, you know this or you don't know this, that why we need to define the tunnel source IP address over here and why we need to define the tunnel destination IP address over here. But here we need to define tunnel source and tunnel destination. Tunnel source will be the public, my public IP address, and tunnel destination will be the remote public IP address. Okay, so I have defined tunnel source IP address, tunnel destination IP address, and now my tunnel interface is up. I am going to create one tunnel on router number 2 now. So let me take you to R2, and here interface, let's say tunnel interface 1, IP address is 192.168.10.2, 255.255.255.0. Done. Tunnel source is 2.2.2.1 and tunnel destination is 1.1.1.1. See, 2.2.2 or 2.2.1 and 1.1.1 is reachable through internet. This is concern of ISP, internet, that their IP address should be reachable with each other, right? And through this IP address I have created the tunnel, and now my tunnel interface is up. Let me check that am I able to ping the remote tunnel 192.168.10.1. See, it's not working, but it should ping, it will ping, guys. Wait, let me troubleshoot it. So IP interface brief, my tunnel interface is up, and this is the IP address of my tunnel interface, right? Let me check on router number 1. I'm going to close some VPC from here. Let me close this one, let me close this one, and let me close, let's say, this one. So I am closing 3 VPC. Okay, now on router number 1, so IP interface brief, my tunnel interface over here is also up, and let me check the configuration on so run interface tunnel 1. So tunnel source is this one, tunnel destination is this one, tunnel destination is 2.2.2.2, ping 2.2.2.2. tunnel destination is wrong here, right? Tunnel destination should be 2.2.2.1, right? So let me correct it. Interface tunnel 1 and tunnel destination is 2.2.2.1. This is the tunnel destination IP address. So run interface tunnel 1. Now tunnel source is this one, tunnel destination is this one. Let me ping the tunnel destination IP address 2.2.2.1. Sorry, this is tunnel destination, that is 192.168.10.2. Ping 192.168.10.2. This is the tunnel destination. If it is not working or it's working now, you can see success rate is 80%, and now this time success rate will be 100%. Now guys, through tunnel interface what we can do, This is guys problem of software only, right? It's working fine, tunnel is fine, right? There is no any issue with tunnel interface. This is how you configure tunnel. Now through the tunnel, what I want, I can share the prefixes. Let's say here we have lots of prefixes. Here we have some network. I want to share this network with router number 2. So I can share through the tunnel interface. On router 2 have also some network. So I want to share that network with router number 1. I can share through the tunnel interface. Okay. So let me show you that what we can do. We can configure any routing protocol or a static routing on tunnel interface. Let's say, let me show you how we can configure the routing protocol. So on router number 1, let's say I'm going to use EAGRP. Now router EAGRP AS number, let's say 10, and network, I'm going to advertise tunnel network 192.168.10.0. I've advertised this network. So this router will start sending EAGRP hello message from the tunnel interface. Yes or no? If you want to debug IP EAGRP packets, EAGRP and AS number 10, or directly I think debug EAGRP timer packets, and now then hello packet, hello, like this. See, it will send one hello message from the tunnel interface. You can see it is sending hello message from tunnel 1, sending hello message from tunnel 1. Right now I am going to disable the debugging and all, and let me do same thing on router number 2. On router number 2 also I am going to configure the EAGRPS number 10, router EAGRPS number 10, and network 192.168.10.0. Soon EAGRP neighborship will come up on tunnel interface. You can see. So IP EAGRP neighbor. Now you can see there is one neighbor 10.1.1.1 on which interface? On tunnel interface. Now there is EAGRP neighborship between router 1 and router 2. So as you know, if EAGRP neighborship is there between router 1 and router 2, we can share prefixes through EAGRP. So what I can do, directly on router number 1, let's say I am advertising on router number 2, I am advertising, let's say 50 network, a router EAGRP 10 and network 50.1.1.0.0.255, or we can skip it. I have advertised 50 network in EAGRP. So now on router number 2, if you will check, so IP EAGRP interfaces. So EAGRP is running on this interface and this interface because I have advertised this network in EAGRP, and router 1 will have network information of 50. Let me show you. So IP route EAGRP. Now you can see 50 network is there, and if you want to ping the user in 50 network, ping 50.1.1.1, you can see it will ping through tunnel interface. 50.1.1.1 is running on switch number 1. Let me ping 50.1.1.2. See, ping is working. Yes or no? Success rate is 100%. And this is how you can share all network, all private network through tunnel interface. Okay guys, so today in this video we have learned how to configure multiple protocol in a topology. Okay guys, and that's all for today. If you want to learn these things in detail and all configuration in detail, please enroll yourself for the live training. That's all for today. We will meet soon in next video. Till then, stay safe guys. Bye bye. See you in next video.